In this video, we're going to look at the behavior of graphs and symmetry again, just a little review, kind of introductory level for both of those. So when we talk about the behavior of the graph, we're going to look left to right is how we read. We're also going to write it as the intervals for the domain, or we could use inequality symbols as well. We don't want to consider the range on these right now. I'm just going to put everything in terms of x's. So we would have f increasing from left to right is that little section there, 0 to 1. I'm going to use curved parentheses because there's not really any action happening at the ends. Or you could think it's just kind of like a dead spot. And then or union, because I want and or in math, union means and or both. So I want this section also. So again, make sure you kind of look it down to the x-axis for the interval that happens on which x's. Well, 2 from this x over to 4. And that is when f is increasing, writing it as x values. Now, if we look at decreasing, I'll write that one in blue. Left to right, we're going downhill, so it's that chunk right there. And remember, we want to just look at the x's, so that would be from 1 to 2. Okay, we don't want to use y values because that's too ambiguous, because we don't need to have unique inputs for our y's, so it wouldn't be really clear what we're trying to state. Okay, now we're going to look at where f has a local max and a local min. Okay, so we want to define what that is. So the max is where y is larger, has a bigger value than anything else around it. So you can kind of think of like a little circle. Like, so this looks like a peak here. This one definitely is higher overall, but that's a local max over there, but this is also a local max for what's surrounding it. So if I kind of put a circle around there and that's in the middle, I would say my local max, I have two of them. I have when x is 1. Again, we want to put it in terms of x. And I also have a local max when x is 4. So just jot those down like that. So that's the max. I have these on the same line. So the x that gives the maximum y is what we just wrote there. And then I want to look at the min. I'm going to put that in blue. Again, kind of think, what's your low point? Well, I have a couple of them. I have, this one doesn't have any bend, but it's still a low point relative to what's near it in its little sphere of influence, right? And also this one. So I would write the min or minimum. So it's the minimum y value occurs at x equals 0 and or x equals 2. Now, a lot of times we're working with estimates here. These are clearly on the grid line, so it's easy to tell, but you know, it's okay if you're a little bit off, like if it was in the middle and you said like 1.2 and I had 1.3, that's okay. Okay, let's take a look at when f is concave up and then concave down. Actually, I'll use red for the concave up to kind of keep with my theme here. So concave up means that you could fill it up and it is not going to pour out. So the water stays in there. Now this one we have kind of go up and then down, and then it has like the switch point right here. Kind of mark that in pink and right here. So that's what I'm going to say for my domain of x values. or, well, it's not the whole domain, it's just like the little interval of x values that goes for my concave up. So it would be about 1.5 to 2.5. And here's where I'm saying, like, it's an estimate, so it's okay. Don't worry too much about that. And then I don't really see anything else on here that looks like remotely being up. Concave down, here's again my switch point, and then I have another one here. So that's where the water would fall out. And I could possibly say maybe right here is a down. It's kind of starting to turn down a little. So that could be a concave down, even though it doesn't really curve under this little piece is. So I would have about a half. Again, make sure you're writing your x values, 0.5 to about 1.5. Again, it should match up to that. And then also union that with right here, maybe 2.7. That's pretty close. And then up to 4. Again, use curved parentheses for that. Now I want you to notice the points of switching. Those are what my inflection points are, not the max or min. So if you have, if you write the max or the min in here for your inflection point, that's clearly wrong. That's the top or the bottom, not where the switch is made. So the inflection point is when it switches. I was using pink before for that. When it switches the bend. Okay, so right about here on that one. So we have a point of inflection maybe at 0.5. Oh, actually, that's not a switch there. That's just kind of going up. It's right here, 1.5, excuse me. X equals 1.5. And then it's going down and then back up. And then it kind of switches to down again at 2.5. And I'm going to write an approximation symbol there, just to clarify that's an estimation. One thing I want to point out, if you had written for the concave down, if you had written 0 there, that would kind of be okay, but we don't want them at a slant. That's why I picked 0.5, because that's like makes like a little cup, upside down cup. Or you could think of it like a little mountain or a tent. Okay, so I want to where that starts. Even though it's not a point of inflection, it's kind of where that edge of that bowl is. That's upside down or cup. Okay, now for part F, we're going to add to the top of the top graph to make it an even function. And we know even functions reflect over the y-axis. That's my fold line. So this is just a review of what we did previously. This page is really just pretty much review. So if I have a point here at 0, obviously my reflection is at 0, 0 also. But if it weren't falling on that, I would have to kind of skip over. You'll see some like that in the homeworks and things. So the next point I might look at is this little half one. So I would go to negative a half, 1. And then I have 1, 1. So I would have negative 1, 1. Or 2. 1, 2. That's 1, 2. So negative 1, 2. So it's the same y output. And then down here, you can kind of do it by looking at your spaces too. Like that's 2 over. So I'm going to go to over this way. Or you could think of like what the actual points are. So this is a positive 2. Positive 1, so I would have a negative 2, positive 1. And then I go kind of back up. So I'm not doing every single point, but I'm doing the key points. So I have a positive 3, 3. So then I want a negative 3, positive 3. And then lastly, I have a 4, positive 4. So a negative 4, positive 4. And then I just have to kind of try to mirror the shape there. And again, I'm not looking for it to be perfect, but I want you to have the right idea. So if you kind of have it like mine's, obviously if I fold it, it's not going to line up perfectly, but that's okay. So that would make this whole thing then be even. Okay, so now that whole thing is even, not just the one piece alone. So now this middle graph, let's make it be an odd function, which is where we are reflecting over the origin here. So it's kind of like we would flip this way and then flip again. Okay, so it kind of goes this way and then, I don't know how to put that, like that way. It's a 180-degree rotation. Or you could think of it on the diagonal. And one of the easiest ways to do it really is just to say, if I have 0, 0, then that's all good. If I have 1, positive 2, I'm going to want negative 1, negative 2. Should be on the graph, right? So I think that's kind of the easiest way to do these. And then here we have a positive 1, 2, 1, and then a negative 2, negative 1 would be on the graph also. And then we have 3, 3, so I want negative 3, negative 3, and 4, 4, so I want negative 4, negative 4. So hopefully you get the idea with that. And then this is what the shape will look like. It's a little hard to do at the end there. I'm just hoping you get the idea, having this little bit of extra practice. And if you feel like you can try them on your own, you know, that's always welcome. That one would have made a good classwork. How about this one will be the classwork. Add to the bottom graph to make the function symmetric about x equals 4. So here's our little piece, and instead of flipping over the y-axis or the origin, for instance, we want to flip over and have our line of symmetry be x equals 4. So I'm going to put a little line of symmetry there, x equals 4, and then see if you can get the shape to flip over that on the other side. Just everywhere you have like a space. So for instance, you know, that's still the same, and then just this one space out, and so on and so forth. So try that, and then I'll fill those in. Sometimes people ask about flipping over the x-axis and what that means and how that works, but that's we can do that, we can say that, but it doesn't have a special name because a lot of times that will make it not be a function. So it's a little dicey of an area to go into. So we stick to talking about odd functions, even functions. We talk about the inverse functions. We talk about transformations. You'll hear them called like flips or something like that, right? Or, you know, reflecting, or kind of synonymous. So that's why we're doing this, so that you're real clear on how to flip or reflect, whatever you want to call it, a certain way. So go ahead and try this and then check back. And this is the last piece of this, so then you can move on to the next part and doing some, there's an activity coming up in your curriculum. Okay, so there's my beautiful picture. It looks like maybe 3 mountains or some kind of weird spider. So have a great day. Thanks for watching.